Welcome to this explainer. I'm so glad you're joining us today because we are going to unlock something absolutely phenomenal. We're looking at how to harness the power of local small language models, or SLMs, right inside Visual Studio Code. If you're tired of sending your proprietary code to the cloud just to get a little AI assistance, you are definitely in the right place. We're going to transform your local dev environment into an absolute powerhouse. Okay, let's dive right into our roadmap for today. We'll start with local models in VS Code, then look at storage and execution basics. After that, we'll cover automating your code documentation, generating dynamic code visualizations, 5 C# project blueprints, and finally, building your local toolkit. Let's get to it. All right, Section 1, Local Models in VS Code. We're bringing AI directly to your dev environment. You know, the days of relying exclusively on cloud AI and crossing your fingers that your API key doesn't get leaked, those days are officially over. Enter the Small Language Model, or SLM. This is a compact AI model that runs entirely locally on your own hardware. So why is this such a big deal? Well, it provides powerful offline analysis without ever sending a single line of your private, proprietary code to the cloud. You get the intelligence of a massive language model, but compressed and optimized to run on the very machine sitting right in front of you. For developer privacy, yeah, this is an absolute game changer. And you've got some truly incredible options available right now directly through VS Code extensions. We're talking Microsoft's highly efficient Phi 3.5 and Phi 4 models, Meta's lightweight Llama 3.2, and specialized coding tools like Qwen 2.5 Coder and CodeStraw. There is even DeepSeek R1 Distill for those really complex reasoning tasks. This brilliant lineup basically gives you the flexibility to choose exactly the right model size and specialty for your specific coding tasks. And the best part? It's entirely for free. Moving on to Section 2, Storage and Execution Basics. Let's demystify the black box. Okay, it's time to lift the hood and see exactly where these models live. It's actually a beautifully simple 3-step process. First up is the trigger. You just select a model from catalogs like the AI Toolkit or Microsoft Foundry Toolkit right inside VS Code and hit download. Second is storage. And no, these aren't hidden in some obscure system file. They're saved securely to your user profile directory, typically in cache folders under app data or a local dot folder. Finally, execution. The models spin up using your local hardware. Whether you're rocking a robust CPU, a dedicated GPU, or a modern NPU, a neural processing unit designed specifically for AI, the toolkit optimizes the execution to match your exact silicon. So once they're running, they expose themselves via localhost endpoints. Depending on whether you're using a Llama, the AI Toolkit, or Onyx Runtime, they will typically open on ports like 11434, 5272, or 8080. What you really need to take away from this is that these ports act as a secure, completely offline bridge. They're exposing an OpenAI-compatible URL right on your own hardware. That means you can seamlessly trick your local scripts and tools into thinking they're talking to a massive cloud provider, when in reality, it's just your laptop doing all the heavy lifting. Section 3. Automating your code documentation. We're going from manual typing to AI batch processing. All right, let's tackle a deeply tedious problem, writing manual docs. It's a task pretty much every developer universally loves to avoid, right? The source guide details 20 practical use cases for these local models to solve exactly this, grouped into 5 heavy-hitting categories. You can automate your documentation, rapidly generating readmes and batch doc strings. You can run code auditing and quality checks to scan for sneaky security flaws. You can build VS Code custom agents by configuring local endpoints in extensions like Continue. You can automate your Git and terminal workflows, hello conventional commits, and you can build specialized offline tools like Local RAG, which is essentially giving the AI a private local library of your own documents to read from. Honestly, the sheer scale of what you can automate right out of the box is staggering. So, the secret sauce to making all this happen is just one simple prompt. Generate clear technical markdown documentation for this code. By setting up a quick Python or Node.js script that hooks into your localhost API, you can write a loop that reads every single source file in your directory, fires this prompt to your local model, and automatically spits out perfect markdown files. Just imagine it, documenting thousands of lines of legacy code while you step away to grab a coffee. How great is that? Next up, Section 4, Generating Dynamic Code Visualizations. Let's go beyond simple text. Now we are escalating from generating basic markdown text to something truly incredible, dynamic visual architectures. Just imagine highlighting your raw code, right-clicking, and stepping beyond plain, flat text into dynamic architecture visuals. Using these local models, you can actually instruct them to output mermaid chart syntax and dynamic SVGs. Instead of just reading a wall of text about how your code works, you instantly see it. The source material highlights this super cool, interactive React application that uses these local endpoints to render 5 specific types of diagrams. You can generate flowcharts to spot pipeline latency bottlenecks, figuring out exactly where your data is getting bogged down. You can create sequence diagrams to visualize API execution timings and payload sizes. You can render class diagrams to understand code coupling so you know exactly how tangled your architecture really is. You can map out state diagrams for transition errors, and you can even generate dynamic SVGs to display raw code metrics, like radio gauges indicating how maintainable the code actually is. Basically, you're turning abstract, dense code into clear, actionable visual metrics. Moving right along to Section 5, 5 C# project blueprints. Time for some advanced implementation. Now, taking this to an enterprise level, what's really interesting here is how each tool maps to a specific developer pain point. We have 5 production-ready C# blueprints here, all leveraging Microsoft Phi models. First up, we have the Roslyn Mermaid DocGen, an AST analyzer, which simply means it reads your code structural tree to generate class diagrams and map out system coupling. Second is the API Sequence Doc Builder, an ASP.NET Core scanner that builds interactive request lifecycle sequence diagrams. Third, the CodeMetrics SVG Exporter. This one calculates cyclomatic complexity, essentially a measure of how complicated your code logic is, and uses the SLM to format raw SVG radio gauges. Fourth, the State Machine Visualizer, which inspects C# enums to build mermaid state diagrams. And finally, the Git Diff Doc Agent. This is a Git hook that runs a diff, queries the local endpoint, and generates visual before and after flowcharts for your pull requests. I mean, this is automated documentation at its absolute finest. And that brings us to Section 6, building your local toolkit. Let's curate your dev environment. Okay, let's talk about how you can immediately start building your own localized AI powerhouse. You only need a few essentials to get started. First, grab the right extensions for VS Code, the AI Toolkit, the Foundry Toolkit, or Llama. Second, and this is absolutely crucial, do a hardware check. You need to match the models to your system's available RAM and GPU VRAM. A smaller model like Phi 3.5, that will fly on a standard laptop, while larger models might need some dedicated hardware. And third, this is completely cross-platform. It natively supports Windows, macOS, and Linux environments. You are entirely in control of your own workspace. We have seen how to download these compact powerhouses, run them securely offline, automate tedious documentation, and even generate dynamic architectural graphics. The barrier to entry for private, offline AI has completely vanished. So, I'll leave you with this. Your code is local. Your AI is local. With these incredible tools sitting right inside your editor, what will you build tomorrow?